In this video, we're going to look at some more challenging examples where we can use binomial expansions. So in this first example, let's just run through and see if we can combine some surds and radicals with what we've done already. So just like before, we're going to say that root 5 is A and 2 is going to be B. We are going to be looking for the fourth line of Pascal's triangle to get us started to find the coefficients of this expansion. So very quickly, let's just keep writing this out until we get to the fourth line. There we go. And we know these will be our coefficients. So we'll write this out, 1, 4, 6, 4, 1. And now we'll put our A's in. So we'll have A running down starting from 4 because we're on the fourth line. A to the 4, A to the 3, A to the 2, A. And then from the right, we'll do the B's starting from B to the 4, B to the 3, B squared, B, just like that. And then we'll put some plus signs there. So we've expanded there, A plus B to the power of 4. So now all we're going to do is substitute in our root 5 for A and 2 for B. So if we do this, just writing this out without simplifying to start with, we're going to have root 5 to the power of 4 plus 4 lots of root 5 cubed multiplied by 2 plus 6 lots of root 5 squared times 2 squared plus 4 lots of root 5 times 2 cubed plus 2 to the power of 4. Now, when we're dealing with square roots, we need to remember some important relationships, and that the first one being that root of anything multiplied by itself is going to be that thing inside there, isn't it? By definition of what a square root is. Right, so if we think then about root 5 times root 5, well, that's just going to be 5, right? So times to the power of 4, we'll end up with 5 times 5, which is going to be 25. Right, if we have this next one, well, we've got 4 times 2, which is certainly 8. And then we're going to have a root 5 times root 5 times root 5. Well, those first two are going to make a 5, and there'll be 1 root 5 left over. So we're going to simplify that in a moment, but that's going to be that. In this next one, we're going to have, 6 times 2 squared is 6 times 4, which is 24. And root 5 squared is just going to be 5. Simplify that in a moment. 2 cubed is 8. 8 times 4 is 32. So I guess we'll just leave this as 32 root 5. And then 2 to the power of 4 is 16. So we can now go back and simplify this again. So, we can join up the 25 and the 16 perhaps, and that's going to make us a 41. As well as that, what else have we got? Well, we could do this multiplication. We've got 40 root 5 there. 24 times 5 is 120. And we've got 32 root 5 still. All right, from there, we can add the 120 to the 41. So that is going to become 161. And then 40 root 5 plus 32 root 5 will give us 72 root 5. So in a case like this, with some radicals, we can simplify quite heavily and leave ourselves with just 161 plus 72 root 5. Now, sometimes we have to deal with even more complex problems, and that would be something that could look like this. So in this case, we have something that could be expanded binomially using Pascal's triangle, 2x plus 1 cubed, and that is multiplying again by x minus 1. Now, we could probably do this quite simplistically without using binomial expansions, but I want to show you an example so you can apply this to more complex problems later. So what we're going to do is ignore the x minus 1 to start with and just worry about the 2x plus 1 cubed. So we can, again, let's just find the third line of Pascal's triangle. We're going to write it out, 1, 3, 3, 1. And by this point, you're probably ready to drop the A and the B, but let's just keep it there just for a bit longer. We'll write it down like this, A to the 3, A squared A, B to the 3, B squared B, and we'll put some plus signs in the middle. We can say that A is 2x and B is equal to 1, and when we can put those numbers in. So we're going to have 2x cubed plus 3 lots of 2x squared. B is just 1, so we'll leave that, plus 3 lots of 2x plus 1, just on the end there. Okay, simplifying again, we're going to have 8x cubed plus 12x squared plus 6x plus 1. So our 2x plus 1 all cubed is going to give us this. Now, we have that multiplying by x minus 1 though. So what I would do is put this into like a multiplication grid, and that is where we're going to make sure we don't lose anything at all, right? So I'm going to draw this out, and we're going to have that 8x cubed plus the 12x squared plus 6x plus 1, and that's multiplying x minus 1. And this will have 8 spaces in it, and those spaces are going to reveal our final answer, right? We're going to expand them. So 8x cubed times x is going to be 8x to the power of 4. 12x squared times x, 12x cubed. 6x times x, 6x squared. And 1 times x is just going to be an x. Then on the lower line, we're going to have minus 8x cubed minus 12x squared minus 6x and minus 1. Now, we could write all 8 terms out, but I can already see some simplifications because we can bring together, for example, the x cubed terms. We can bring together the x squared terms. We can bring together the x terms. So writing those out, we're going to have 8x to the power of 4 plus 4 lots of x cubed minus 6x squared minus 5x minus 1. That's how we're going to get that answer. Okay, that should be all of the non-calculator style question examples that we have.